Imagine a celestial traveler streaking across the sky, leaving behind a glowing tail that stretches millions of miles. What forces create this breathtaking phenomenon? Comets are among the most fascinating celestial objects in our solar system, their tails stretching millions of miles across the vast emptiness of space. As they journey through the cosmos, these icy wanderers undergo dramatic transformations, revealing the forces that shape their existence. Their tails, shimmering in the sunlight, are not just beautiful but also rich with clues about the early solar system. These long trails of dust and gas, extending far beyond the nucleus, form when the comet approaches the Sun and its frozen components begin to vaporize. The delicate interplay between solar radiation, charged particles, and interplanetary forces orchestrates a spectacle that can be seen across great distances, sometimes even from Earth. As a comet ventures closer to the Sun, its solid nucleus, a mixture of ice, rock, and organic compounds, begins to sublimate, releasing vast quantities of gas and dust. This process forms a glowing coma around the nucleus, a temporary atmosphere that eventually stretches outward, giving rise to the comet's tail. The tail is not a singular entity but rather a combination of two distinct structures, the ion tail and the dust tail. The ion tail, composed of charged particles, is shaped by the solar wind, a constant stream of charged particles emanating from the Sun. This tail extends directly away from the Sun, regardless of the comet's trajectory, as it is controlled by electromagnetic forces rather than the motion of the comet itself. The dust tail, on the other hand, consists of small solid particles that reflect sunlight, curving gently as they follow the comet's orbital path. The sheer scale of these tails, sometimes stretching hundreds of millions of miles, is a testament to the immense energy imparted by solar radiation and space dynamics. The color and composition of a comet's tail provide insights into its makeup and the conditions it encounters in space. The ion tail often glows blue due to the presence of ionized carbon monoxide and other charged particles that interact with solar radiation. This eerie, ghostly glow can be observed through telescopes and sometimes even with the naked eye. Meanwhile, the dust tail appears yellowish or white, reflecting the sunlight that illuminates its tiny particles. As the comet moves through space, the two tails can diverge dramatically, revealing the influence of solar wind and radiation pressure. The study of these tails has allowed scientists to understand the composition of primordial solar system material, as comets are believed to be remnants from its formation. These ancient time capsules carry volatile compounds that were present when the planets were still forming, making their tails not only visually spectacular but also scientifically invaluable. Some of the most famous comets in history have displayed tails that astounded observers and challenged scientific understanding. Comet Hale-Bopp, which became a celestial spectacle in 1997, sported a tail over 100 million miles long, stretching across a significant portion of the night sky. Similarly, Comet Hyakutake in 1996 displayed an incredibly long tail that provided astronomers with a rare opportunity to study its structure and behavior. Halley's Comet, which visits Earth's vicinity every 76 years, has a tail that has been documented for centuries, even appearing in ancient artwork. The length and brightness of a comet's tail depend on various factors, including the comet's distance from the Sun, its composition, and the activity level of the solar wind at the time of its passage. Some comets, after making their journey through the inner solar system, leave behind trails of debris that contribute to meteor showers when Earth passes through their remnants. Despite their ethereal beauty, comet tails are ephemeral structures that exist only while the comet remains close to the Sun. As the comet moves away, its sublimation slows, and the tails gradually dissipate into the vastness of space. However, the materials released can persist, spreading out into interplanetary space and sometimes forming vast dust streams that continue to interact with planetary atmospheres. Studying these tails has not only deepened our understanding of comets but also shed light on the dynamic processes occurring in the solar system. In the future, as space exploration advances, missions may allow us to sample cometary tails directly, unlocking even more secrets about the origins of our cosmic neighborhood. Until then, comets will continue to grace our skies, their luminous tails stretching across the heavens, a reminder of the cosmic forces that shape our universe. As comets journey through the cosmos, their luminous tails reveal secrets of the early solar system. What other cosmic wonders await discovery in the vastness of space?